For today's mock coding interview, we have a third year college student who got All India Rank 1 in Kickstart 2022 A round. He is an incoming GS intern who got All India 20 rank in ICPC 2021 regionals. He is a 6-star on Code Chef and a candidate grandmaster on Code Forces. Meet the fellow YouTuber Priyansh Agarwal. Let's see how he does in the mock coding interview. But before that, let me tell you about the sponsor of the video. As you're watching a DSA interview video, most probably you want to become a good software developer, and you know that most companies take technical interviews on DSA to hire beginner software developers. But is DSA enough to get you hired? You know the answer to this question is no. That's why I'm telling you about AccioJob, founded by IIT Delhi alumni. They train graduates and final year students in a 6-month full stack development course and get them placed in a software development role. The best part is that AccioJob will take the fees once you start receiving your salary, and that too if you get a CTC of more than 5 LPA. That means you get a 100% job guarantee. So far, the highest CTC that this student has got is 41 LPA, and their average CTC is 8.3 LPA. And they have already partnered with 190 plus companies. More importantly, AccioJob has the minimum fee and payback period of 12 months when compared with any other pay after placement program. The most fantastic news for female software engineering aspirants is that AccioJob has announced that they will pay 25,000 rupees for any girl who joins their program to promote women in tech. What are you thinking? Take your first step towards building a tech career by going to AccioJob's website now. Link is given in the description below. So Priyansh, this is your question. Just read through it and let me know if you have any questions.
Sure. So you have been given a string count number of subsequences of the form AIBJ-CK. It consists of IA characters followed by JB characters followed by KC characters.
Okay, so it has not been pasted properly. It actually means A power I, B power J, C power K.
Okay, I see. So basically, if I have to write a case here, so let's say I equals to 2, J equals to 1, and B equals to, let's say, 3. So then you want me to find a subsequence like AA, B. Sorry, this should have been K, right? Yeah, this should have been K. AA, B, C, C, C. This is what you need me to find, right?
Right.
Okay. So we have to find the number of subsequences of the form. All right. And two subsequences are considered different if the set of array indexes picked for the two subsequences are different.
Yes.
All right.
Let's take an example. If the input is A, B, B, C, what will be your output?
If my input is A, B, B, C.
C. Yeah.
Right.
What are the possible subsequences?
Yeah, sure. So the possible subsequences could be, first of all, we could have A, then we could have B, then we could have another B, B and C. These are the subsequences of length 1. Then as far as length 2 are concerned, then we can, have A, B, 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 C. Then we can also have A, B.
One second, Priyansh. So note that we have written characters where I is greater than or equal to 1, J is equal to greater than or 1, and K also. So at least one A, B, and C should be present. So in this case, the possible answers are ABC, ABC, and ABBC.
Right. I was assuming that you wanted me to print all the subsequences. So
no.
All right.
IJK have constants.
Okay. So are these IJK and IJKs given to me, or they can be arbitrary, but they just have to be greater than or equal to 1?
They can be arbitrary, just that they have to be greater than or equal to 1.
All right. So it just means that I have to pick up a subsequence like A, B, C, and the number of A's, the number of B's, and the number of C's should be at least 1. Right.
Yes.
So yeah, the subsequences that I can have are A, B, C. Then I can also have A, B, C. We can have two types of A, B, C. The first one could be when we have picked up the first A, the first B, and the second one could be when we have picked up the second B.
Right.
Right. So these are the two subsequences that I can have here. Fine.
There is one more possibility.
All right. Let me think about it.
ABBC, because in that case J will become 2.
Right. The whole string itself can also act as a subsequence here. Yeah. So we have ABC, ABC, and ABBC. So the answer here should be 3, right? In this case, that I have to return.
Yes. Yes. Perhaps calm down. You're doing great. Like calm down and go through all the cases. Okay.
Yeah, sure, totally. All right. So, fine. I mean, the very first idea that comes to my mind is, to check all the subsequences that we can generate, right? So, I mean, I just have to consider this, that I am picking up at least one A, at least one B, and at least one C. If that is happening, then, I can be sure that the subsequence that I have picked up will contribute at least, to my answer.
Right.
Right. So maybe, I can do a recursive thing here wherein I can just check, which index am I at right now. For example, let's say I have been given a string S, something like A, B, B, A, B, B, C, something like this. I mean, I'm considering this as an example, right? So I'll start with the very first index and I'll have two possibilities. I can pick up the first character or I can not pick up the first character. So let's say I pick up the first character, then in that case, I have already picked up at least one A. So when I get to the next index, I will have in my mind that I have picked up at least one A, so I don't really care about whether I pick up more A's or not. I can also pick up B now.
Okay.
Right. So it's basically like, whether if I'm at any index, I can basically represent, I mean, I can take a variable which tells me which all characters have I already picked up. For example, if I've already picked up A, I mean, I can have three variables, for example. I can have Boolean A, Boolean B, and Boolean C. So obviously, I cannot make my Boolean B true even before I make my Boolean A true, because I have to pick up an A first, right? So let's say, I mean, I can define like a very small function here. For example, if I have a function which returns, valid subsequences. So I have, three variables here, and I also need an index as to where I'm standing in the, a string that has been given to me. So first of all, I will have my string, and I can pass it by reference so that I don't make a lot of copies. Then I have three variables, Boolean A, Boolean B, and Boolean C, right? And the next parameter that I need is the index inside this whole string.
Just to be sure that we are on the same page. So Boolean A means whether you have taken at least one A.
Right.
Right.
So I think I should actually define this thing. That would be much better. So Boolean A just represents have I picked up an
Yes,
A
this
or
might not be the most optimized solution, so don't spend so much time in writing proper code. Let's discuss the approach first.
all right.
And if we think this is the most optimized approach, then let's write the proper code. Okay.
Sure, totally. So first of all, I have three parameters: Boolean A, Boolean B, and Boolean C. So let's say I'm at any index, and let's say I have Boolean A and Boolean B as true. This just means that I have picked up my A and I've also picked up my B. So now from the next index, I can either pick up a B or I can pick up a C, right? Similarly, if I just have my Boolean A as positive and Boolean B and Boolean C as, I mean, if I say that my Boolean A is true and my Boolean B and Boolean C is false, it just means that I have picked up a single A, and now I can pick up more A's as well, or I can pick up a B, right? I mean, is it making sense?
Yeah, it does make sense.
Right. So if I talk about, considering all the possibilities, this structure that I have in my mind will cover all the possibilities, but this is highly, it is not very optimal. So I'll be considering all the 2 to the power n possible subsequences here. So yeah, I mean, the complexity will be exponential in this case.
Right. And how are you maintaining the count?
Actually, I don't really care about the count because I just want the number of total subsequences. I don't really care about how many A's have I picked up, how many B's have I picked up.
Okay.
Right, because like in this case, we had ABC and we also had another ABC, right? So it doesn't really matter if we pick up the exact same, string. All that matters is we are picking up different indices.
Okay.
Right. So if I consider this, recursive approach, it will consider all the possibilities, but the solution is obviously exponential here.
Okay. So I'm expecting a much better solution, definitely not exponential. So can you think of any optimization?
Yeah, definitely. I mean, since I'm, representing my function in this form, all I need is one index as to where I'm standing in the original string. And then I have three parameters, Boolean A, Boolean B, and Boolean C. So obviously, we are having a lot of overlapping, problems that we are solving basically. For example, I could have, let's consider a case here. For example, I could have picked up something like AA, BB, C, right? And now I'm standing at, let's say, just a minute. Let's say this is my original string. I have some characters here. I have basically processed the string till this point, and now I need to process the string after this point. And while I was processing the string till this point, I've already picked up, let's not consider C here because then it will be obviously a trivial case. So let's say I've already picked up AAA, BB, right? So after this point, I have two possibilities. Either I can pick up a B or I can pick up a C. I can never pick up an A because I've already picked up a B in the middle, right? So the thing is that all I need at any index is, first of all, the index. Then I need whether have I picked up array, I mean whether have I picked up A or not. So that will be like a Boolean parameter again, Boolean A, then Boolean B, and then Boolean C. And the condition here is that I can never make my Boolean B as to true, even before I make my Boolean A as true. So these will go in a sequential order. First of all, Boolean A will become true, then Boolean B will become true, then Boolean C will become true. Right?
See, Priyansh, actually, if you divide the string such that you stop taking you're dividing it at a particular index, and then you're taking A's only before that and not after that, right? Then the complexity will be more anyway, right? Let me straightforward tell you that I'm expecting a time complexity of order of n.
Yeah, I mean, I am coming to that exactly. I was trying to think about a dynamic programming approach, and my dynamic programming state will be represented by these four parameters. That is what I was saying here. Right.
But how will you be able to? Okay, can you tell me the recursive formula that you're going to use to come to the dynamic programming?
Sure. So how about I, give you a state, a transition, and like a final subproblem?
Yes.
Would that be
Yeah,
fine?
please do. Yeah.
Sure. So I will be having my state as something like. Should I move to the next page? That will be much better.
Yeah.
Right. So I have a dynamic programming solution in mind with state being dp of index A, B, C. Now, what does this represent? This just represents, I am standing at index. I am standing at index in the original string, and these three parameters define my whole structure that I have picked up till this point. For example, I mean obviously there are 8 possibilities here, so I can consider all 8 possibilities for A, B, and C because all of these parameters are Boolean, right? So I can represent them as 0 and 1, 0 being false and 1 being true, right? So the three possibilities are 0, 0, 0. What does this mean? This just means that I have not picked up anything. I haven't picked up A, I haven't picked up B, I haven't picked up C. Similarly, if I have something like let's say 1 and 0. So this just means I have picked up some A's and some B's. Now I either need to pick up more B's or I need to pick up a C. Right? Similarly,
some meaning 1A and 1B in this case, right? 110 means?
No, 110 means this. I have picked up some A's, some, just a minute, some A's.
You don't know how many A's and how many
Yeah,
B's.
because we don't really care about that. We just need to find out the number of subsequences. We don't need to consider how many A's have we picked up in particular.
Okay.
Right. So similarly, and the thing is that I can never have a state as something like, being 0, 1, and 0. What does this mean? This means that I have picked up some B's, but I haven't picked up any A's. But that's not allowed, right?
The value at this, like 110 is like index, right? So, so what is the value that you're storing there? The number of, number of subsequences possible of the form ABC itself.
Yeah, so the state actually represents that if I have dp index ABC, I am standing at index in the original string, and now I need to find how many subsequences are possible in the suffix of the string, starting from index.
Okay.
Right. So this is the
formula also.
Yeah, this is the number of subsequences starting at index, obviously index, in the suffix. Right, and this is the state, and I can represent the transition now. So obviously, if I have, let's say, index A, B, and C. So now there are cases here. So first of all, the case is that if A is true or not. So I have one case which is like A is true, or let's say we have the very first case as A is false because I haven't picked up anything. right? So I'll check at my current index whether there is an A or not. If there is no A, I cannot pick up it. I can not pick it up, right? Because I have to pick up I have to pick up A's first of all, right? So if it is false, I need to consider this. If string at or we can represent the string as S. So if S at index equals to A, then I can have my DP of index A, B, comma C equals to DP of, because obviously now I'll be moving to the next index, index plus 1, A, and obviously since A was false before, now I'll have to make it true, right? Because I have picked up an A here. So this will be DP index plus 1, true, and then I have C. Right, this is one possibility. Another possibility could be that I don't pick it up. I don't pick up this character, right? So let me bring this down. There are two cases. DP of index plus 1, and I'll leave A as it is. I won't change it because I'm not picking up any A here. So I'll leave A as it is and B as it is and C as it is. So this was the case when I have A as false.
One thing, okay. So here you are saying that DP, whatever value your DP basically array is storing, right? It is the number of subsequences of the form, of form A power I, P power J, C power K, right? Right? A, I, B, J, C, K. I'm just writing it like this. Now see that when you're saying that A is false, right? That means basically it is not possible that the form is there because your condition itself becomes false, right? So shouldn't the value be 0?
No, so that's not how I am defining my DP. I mean, I'll tell you a base case first of all. The base case should make it very clear. So when I reach the end of the string, let's say I have N, and now I have A, B, and C. So now, if I've already reached the end of the string, I need to have at least one subsequence with me, right? So, I mean, obviously, if I've reached the end of the string and I don't have a subsequence, then I'll return 0. But if I have a valid sequence, then I'll return a 1, because that is one valid subsequence, right? So now the case is very simple. If A equals to true, B equals to true, let me just define it formally. If A equals to true, B equals to true, and C equals to true, then I'll return 1, else I'll return 0. What does this mean? This just means that when I've reached the end of the string, now I need to have a valid sequence. If I have a valid sequence, I'll return 1. If I don't have a valid sequence, I'll return 0.
Can we dry run for A, B, B, C?
Yeah, sure. We have A, B, B, C. So I have A, B, B, C. So initially I'm standing at, I'll define my DP as index 0. The value of A is 0, the value of B is 0, the value of C is 0, right? So now I have two cases. Either pick A or don't pick it up. Right. Now let's consider the very first case where I pick up my A. So if I pick up my A, my new DP state will be what? We'll reach the first index. Now my, value of the parameter A will become 1 because I've picked up an A. Right. So that becomes 1. The other states are 0 itself. Right. And if I don't pick it up, the other possibility is very simple. We don't change anything, but we change the index. Right. Now let's say we reach the, second. And obviously, can you see that, the case here will never return a valid answer, right? Because already we haven't picked up the only A that was available.
Okay, so how do you go ahead? Now you call the function again for these two cases, right? Now
So
when you
let's
call the function for the first case, what happens?
yeah, let's consider the first case first. So when I get to the first case and I reach this B, I have two possibilities. Either I can pick this B or I can not pick this B, right?
Yeah.
So let's say I pick this B, then my state will be 1, 1, 1, 0. And if I don't pick this B, my state will be 1, 1, 0, 0.
0, 0. Yeah.
Right. So let's consider the first case from this case. Right. And now if I reach the second B, I have two possibilities. Either I can pick it up or I can not pick it up. But in both cases, my state won't change. My state will remain this only. 0. Right. So at the end, when I reach my C, when I get to the C, And let's say, I mean, obviously both of these are same, so I can write 2 into this, right? Both of these states are same.
Right.
So I can consider just one case here. I write 2 into this. And now when I get to my C, obviously I have two possibilities. Either I pick it up or I don't pick it up. But if I don't pick it up, I won't get an answer. I mean, that's handled in the base case here, right? I'm not really sure if I... Yeah, here. So if I get to the end of the string and I don't have my A as 2, B as 2, and C as 2, then obviously I'll return false here, right?
Got it. Yeah.
Right. So in this case, I do have to pick up my C. That's the case here. And I'm considering this case. So what happens is this. I do 1, 1, 1, 1. Sorry, this had to be... I'm also changing the index, right? Just a minute. I'm also changing my index here.
That's fine, yeah.
Right. And when I get to this fourth point, I mean, fourth is the index when I'm outside my string. Right. And this, as I said in the base case, if all of the parameters A, B, and C are true, I return a 1. Right. So this function will return to this point, and I will have my answer as 2.
Okay.
Right.
I understood. Dry run will work. What will be the space and time complexity of this?
Just a minute. So obviously, I have a state as something like dp of index comma A, comma B, comma C. Now my index can range from 0 to n. So I have my parameters going from 0 to n, and all the other 3 parameters go from 0 to 1. Right. So it's like just a minute. Let me just write it. 0 to 1. So obviously I have 8 cases here. The number of possible cases here are 8 because 2 into 2 into 2. And then I have n, indices. So my space complexity will be 8 into n. That's basically like order of n only.
Yeah.
Right? And when we talk about the time complexity, since all my transitions, I think I haven't really mentioned the transition yet. So basically I was covering all the cases. I was covering all the cases, but it's kind of hard to write all the 8 possible cases. So the time complexity again will be order of n only, because there are order of n states, and for every state I require a order of 1 transition time.
Okay.
So this is my, I'll just write it. Time is order of n and space is order of n as well.
Perhaps this is a good enough solution. I'm sure you can code it, but if I want to challenge you more and I say that I want space complexity of order of 1, can you think of a possible optimization?
Yeah, definitely. It's kind of very simple to look at this. First of all, since my state at any index is only depending on the states at the next index, right? For example, if you look at this, dp of index is only dependent on all the states of dp of index plus 1. So it's like for example, I'll write it like this. So let's say I have my dp array, and obviously this will be like an 8-dimensional array, but I'm making a 1-dimensional array here. So if I have these values, let me just write it as A, B, C, D, something like this. So if you look at A is only dependent on B. A is not dependent on C here. My index, the value at any index in the DP array is only dependent on the value in the DP array at the next index, not any other index.
So for every index, you're going to store 8 values basically.
Right, and basically I won't need to store this index then.
Okay.
Right. So basically, and obviously, if I have to optimize the space, I cannot make a recursive function. I'll have to write an iterative code here in that case.
Right. Okay, let's write the iterative code with the space optimization.
Sure. Let me move to the next page itself.
Yeah.
So just a minute. Yeah. So let's say I have a function which returns the number of valid subsequences, and there's just one clarification that I needed. So if you look at this value of n, can we define the length of the string as n?
Yeah.
Right. So if you look at this value of n, I just want to know how big can this n be? Because if it is, let's say, something like 100, if n is equal to 100, or maybe if, let's say, n is equal to 1000, then the number of possible subsequences could go to up till something like, 2 to the power 1000. So that will be like a very big number. So I want to know if this n is small so that I can fit into my integer maybe.
I can assure you that the answer, the count, the final count, will be within the bounds of integer.
All right. Then we don't really care about the value of n. If that's already said in the problem. Fine. So I have my function which I'll be writing as get valid subsequences. And I have, first of all, I'll be having a string. So I can have string like this, right? Do I need anything else in the input? These
No,
ijk are
that's it.
arbitrary. We only need the string, right?
Yeah.
Fine. So how about, first of all, I write a solution that is, not very efficient in terms of space, like order of n space only. And then maybe I optimize it to order of n space. Would that work?
Yeah,
Or
sure.
cool. So I have my, vector of dp. So I have something like, this. Or maybe I just, define it in terms of int, because I'll have to write a lot of code if I define a vector. So let's say,
Yeah.
first of all, I take the length of the string. Dot length. And then I have, the parameters as n, 2, 2, and 2. So this is like my dp state. Right, and as far as the base case is concerned, I was saying that, if you have, let me just consider the base case here. If you have dp of n, 1, 1, and 1. This just means that I've reached the end of the string and I have all of my parameters as 1. So this will be 1. Because
Right.
that's a valid possibility. All of the others will be false. So can I just assume that all of them are 0? All the,
For
all the,
any indexes, when your ABJ values are 1, 1, 1, shouldn't the value be 1?
oh, no, it should not be 1 actually, because we can have a case like this as well. For example, let's say I have a case like this. I have already picked up my string as ABBCCC. Now I want to, pick up more C's, let's say. So if I just return a 1 at this point, this possibility won't be considered.
Correct.
So I just need to reach the end of the string, only then can I return a 1.
Correct.
Right, and here I'm assuming that all values are 0. I mean, this basically this DP
Yeah,
whole
yeah.
array is filled with 0. Right. So obviously, since I, if I'm at any state or if I'm at any index, it depends on the indices after that. So I'll have to write my code from right to left. Basically, the loop will run from right to left.
Right.
Right. So I can have something like this: int I equals to n minus 1, I greater than equal to 0, I minus minus, and I can, write it as index, because then it will be much clearer as to. Right. So now, there are certain cases where I mean, obviously there are 8 cases here, but most of them will be 0 because they're not possible itself. Right. For example, something like, dp of index, comma, 1, comma, 0, comma, 1. Something like this will have to be 0 because that's not a valid possibility. Right. Because I cannot pick up my C before I pick up my B.
Right.
Right. So if I just define my, states which are actually 0, I'm not really sure if I, should be writing it using a for loop maybe, because there are 8 cases here.
Why don't you write down all the 8 cases like separately so that you know that you're handling all the cases?
Okay, sure,
Like
sure.
just
That's a
like
good one.
comment it out and yeah.
Maybe, yeah, I'll just write it here itself because I'll be considering
Yeah.
all cases then. So I have 0, 0, 0, right? Then I have 0, 0, 1. And obviously this will be false. This will not be false. So I have to, do this. So I'll write a to do here. dp index 0, comma. I have 1, comma, 0, comma, 0. This will be 0 as well. This will be 0 again. Then I have dp of index 1, 0, and 0. So this I have to do again because that's a valid possibility. Then I have dp of index 1, 0, and 1. This will be 0 again. Then I have dp of index, comma 1, comma 1, comma 0. This will be 0 again.
One way to write the code would have been if we would have written like 3 for loops from 0 to 1 and put the check if I is greater than j, then just make it false. That is just one way to do it because it's just 8 values. We can write code like this, but just stating for our audience also, right? Yeah, go ahead.
Right. So I should continue with this, right?
Yeah.
Okay. So I have dp of index, comma something like 1, 1, and 1. This will be I have to do. Right. Okay. So first of all, I don't really think I need to cover all these 8 cases because the cases that I'm really concerned about are only,
These three.
this 0, 0, 0, 1, 0, 0. I think I've missed this case as well. This is 2, 2. So I just need to consider 4 cases. So I don't think I should just comment this part out just a minute.
Just one sec. Let me go through all the cases. Okay, got it. Yeah.
Right. So how about we begin with the very first one? So let's begin with this one. So obviously, if I have 0, 0, 0, I have to pick up at least one A first of all. So I'll just check, if S at index equals to an A or not. Right. So if it is equal to an A, I have one possibility, which will be like dp of index plus 1, 1, 0, and 0. Right. This is one possibility. Another possibility could be that I don't pick up this index. Right. So the very first, possibility at any case is to just not pick it up. I mean, if you are at any index, a possibility which is common to all of these states is that I don't pick up that index. Right. So I'll just write this part here itself. Let me just increase the font a bit. So I have index plus 1, 0, 0, and 0. So I have 2 cases. I can just write it down. I have this one case where I'm not picking up this index. Right. The second case is this one, where I pick up this index only if that index contains an A, and if it does not contain an A, I just don't consider that possibility.
Sorry to disturb. One question. Is there any DP of index where like value at 0, 0, 0, all 3 values as 0 can be non-zero? Like can the value be non-zero at any place, or will it always be 0? Like when the number of A's, B's, and C's is 0, what will be the DP value at any index?
I mean, that's defined by this transition, right? This transition. So it's not like, if I have, this transition speaks for itself. I am just considering 2 possibilities, right? So there is a possibility where I just have 0, 0, 0, and I have my answer as non-zero.
Yeah, so that's why. Okay, so you have added. Okay, I thought you're not adding. But shouldn't you add it to the condition? Okay, give me 1 second. If it is A only, then you are not picking it. Okay, yeah, it's fine. Sorry.
I think I should have explained this ternary thing.
No, it's fine. I was thinking in the wrong direction. Yeah, continue.
All right. So there are 2 cases here. The first one is where I don't pick up this index. The second one is where I only pick up this index when it contains an A. Right. And similarly for this case tells me that I have already picked up my A. So I can obviously pick up more A's, right? It's not like I cannot pick up more A's. I can also pick up more A's. So basically, if I pick up an A, then I obviously won't be changing the second bit here, which is the Boolean B. So first of all, let's consider the case where I don't pick it up, where I don't pick up this index itself. So I have index 0, 0, 1, 0, and 0. Right? This is the case where I don't pick it up. The second case is where I think that this index contains an A. So if I set index equals to A, then obviously, my second bit won't be changing, and my first bit won't be changing as well. So I have 1, 0, and 0, and then I have a 0. I mean, this is just saying that I don't consider anything. And there is another case where I have a B, because now I can pick up my B as well. Right? So if I set index equals to a B, then I have obviously DP at index plus 1, and now the second bit will be 1 as well, because I have picked up a B as well. Right? And so these are basically like 3 cases for this particular DP.
Okay.
Right? I mean, it's very quite not readable actually, but
no, that's fine.
Yeah. So this was it only.
Do you have 2 more to go, right?
Yeah.
Write those down.
Yeah. So I'll just write it very quickly then. DP of index plus 1, where I don't consider anything. And now I can either pick up a B or I can pick up a C. I think I should just copy this part.
Yeah.
So the first possibility is where I don't pick up anything. The second one is where it is a B. I can obviously not pick up an A now because I've already picked up a B. So this is this. Then I have 1, 1. Yeah, this is fine. And another case is where I have a C. So I have index 1, 1, and 1. And the last case is very simple. I can only pick up a C now. So I have just, let me just paste this itself, and then I can change it. So I have 1, 1, 1, and then I have, obviously it should be a C now. So 1, 1, 1. Right, so these are the cases that I have. I mean, there are only 4 valid cases. The first one is this one, the second one is this, third is this, and fourth is this.
Give me 1 second to just go through the code.
Yeah.
For the last case, if it is A or B, don't you need to add anything answers?
No, because I've already picked up A, B, C, so I cannot pick up an A, or I cannot pick up a B now from this point.
Okay. Okay. Similarly, in the last second case, since you've already picked up B, you can't pick up A.
Right.
Okay, correct. Yeah. This works for me. This looks good. But for our audience and for our healthy discussion also, I want to discuss an approach where, I mean, this is the approach that I had read somewhere, and I had also thought of this approach only. So just wanted to share it, and we can discuss along the same lines, right?
Sure.
But this is good. Like, we can end the interview till here, okay, and then we can do the discussion. So one way to deal with this question, through which I think the code will become much smaller, is that as you go through the string, as you traverse through the string, you just maintain 3 counters. One counter is of all the strings, or basically subsequences of the type AAA. Basically, there are just A's. Okay. Okay. Let me write in the next page. So basically, A power I. Right.
Right.
Second number that you store is of the type A power I and B power J. Okay. And the third one that you store is A power I, B power J, and C power K. Right. So this is your final answer. Now, when you traverse through the string, what you do is you check whether this value at that particular index, basically if S of I is equal to A, right? That means you already had some counter of the type where only A's were present, right? Now you can choose to either add this or not add this, right? Or you can choose to just take this one new single A and not take any of the previous A's that were taken, right? If we choose this one single A and not take any of the previous A's, then the counter is 1, right? And if we take or don't take this A, so the value will be 2 into whatever the value was there till now.
Okay, yeah, makes sense.
Right? Now, if S of I is equal to B, right? You tell me what will be the case in this, because I've told you the approach. Now you tell me what will be the value if S of I is equal to B.
Sure. So since we are considering B, then A's have to be picked up, right? So we are basically considering, first of all, this first case where I have picked up some A of I, right? So that's one possibility. I have A of I plus, now I can also consider this possibility. So I have 2 times A of I and B of J. How do I write it?
Exactly. Exactly. So you can just choose to take this one single B, which is the first case that you have taken, AI. And then you can choose to add the B or not add the B to the previous AI BJs, right? So this will be the case. Now, similarly, if S of I is equal to C, what will be the answer? Can you calculate that also?
Sure. So if we have this, then first of all, I can consider the case where I have AI and BJ. So I have AI and BJ, and then obviously it's like 2 times AI, BJ, C, K.
Correct. So this would have been a very simple solution, like as you go through. That is why in the starting I was trying to tell you that don't like divide the index, but this would have been a simpler approach. But I am definitely impressed by the approach that you gave. You were able to think of all the cases, and that in terms of time and space complexity, it is still the same only. So kudos to that. You were able to think of a solution by yourself and were able to write it. I actually thought that when it came to writing all the 8 cases, you would get a bit annoyed that, okay, writing all the 8 cases, but you did handle it with calmly. to give you like the structured way, to push you in a structured way. I asked you to write all the cases, otherwise we would have missed something.
Hmm.
Otherwise there would have been some communication gaps. Since we are doing this for YouTube, I think it's better to write down all the cases and then remove one by one, right? But I think you handled it well. How was your experience? You tell me, how was your experience of interview?
I think it was great. First of all, there was some communication gap when I was, telling the recursive approach, and then I wanted to get into the DP approach. So maybe you thought that I was actually getting into another recursive approach, maybe, but I was getting
Correct.
into the DP approach. So that was like an issue from my side. I should have, conveyed it in a better way. As to now, I am proceeding to the DP solution. So that was one thing. Overall, I really liked the problem. Actually, I mean, there were some cases involved here, so it could have been, really overwhelming if I would have, gone into some other direction itself. So yeah,
Right.
it was really a great experience.
I would say it was not like you were not communicating well. You were definitely communicating well. I should have probably given you more time to talk. It's a two-way communication, but I don't think there was such a huge gap or anything. I think you did well. I initially thought that you were a bit stressed out, so I was trying to calm you down and trying to structure you more. But I did not know that okay, you are already going in the DP direction. So initially, I thought if you start writing the entire code, you might end up wasting some time, and I wanted you to,
Hmm.
save your time. But if you see, we are done well within time. It's just like 40. It's just less than 40 minutes now. And we were able to discuss the feedback, the question in detail. And this is a hard question. This is not an easy question. So the fact that you directly came with recursive and you were able to store the values and do it so soon is definitely awesome. And you wrote code without any you were not worried while writing the code. I could see that you're very, very comfortable. That is a thing that you look for in a programmer, right? It's one thing to have the solution in your mind. It is another thing to be able to translate it, especially when there are a lot of cases. I have seen a lot of people who just get annoyed and they're like, I'm not writing. I know what to do, but when they start writing the code, they are not able to. Since you do have a lot of competitive programming practice, I guess that is not the case with you. Uh,
Yeah.
any last thing you would like to say in the interview? Anything for the audience?
There's just one thing. First of all, obviously the problem was not very straightforward. I mean, it was a difficult problem. But I just want to say to everyone that if you found this problem really very difficult and you were not able to solve it on your own, it's just totally fine. I mean, the reason why I was able to come up with the solution very quickly and code it up so efficiently was that I've already solved a lot of problems. I have almost solved around 3,000 problems on all of the competitive programming platforms combined. So it's just that you don't have to get scared out of this whole interview. It was not like we were trying to scare away anybody that you will be getting very hard problems. This was a problem that I don't think will be very common in most of the interviews. So you don't have to be worried about this.
That's so nice of you, Priyansh, because I've seen people who are able to do hard questions and they get very overconfident that we can do what others can't do. But I can see that you're very down to earth and you're trying to motivate others, and that's the kind of attitude I think which will take you a long way. I mean, solving questions, if you put in the time and the hard work and energy, I am sure anyone can do it. But finding the right attitude is the hard thing. And I think if you are trying to motivate people, then you are definitely doing a great job. And you teach others and you help others also. So I can see the attitude definitely in the right direction.
Thank you so much. Feels great to hear
And
this.
yes, and thank you for coming and doing this. Again, like when we take hard questions, it is not like I want to demotivate something. It's not like I would have picked this question with anyone. If there was any other second, third year student, even experienced people, I would not pick this question because you're a competitive programmer. Because I know you have done so many questions. I wanted to bring a hard question to the table and see how you do it and show that also to the audience that this is possible. But being asked this level of question in a normal coding interview is very rare. I don't think any company would do that, right? Even Google, Amazon wouldn't ask this hard level questions, I'm pretty sure. So, yeah, so but this shows that how much level of clarity you have and how much you have practiced. So, kudos for that. You are motivating so many people.
Thank you so much for these kind words. There's just one more thing that I wanted to add. So it's not like, not any company would ask such a question. So there are companies like, Code Nation and maybe Uber, I guess. So for these companies, you can expect, problems up to this level as well. So, but for most of the companies, like I would say 95% of the companies, all the problems that you'll be getting would be sort of close to lead code medium and, maybe sometimes lead code hard, but not as hard as this.
Right, it's subjective. I would still say Uber wouldn't ask, maybe coordination, yeah. But again, anything, it depends on the interviewer completely,
Yeah.
right? So I also feel that harder problems are nowadays asked for freshers compared to experienced people, because experienced people know, and interviews also know, that freshers can put in more time for competitive programming and not in general, right? So,
Mhm.
yep. Thank you so much for coming and doing this, and I hope you had a good day.
Yeah, totally. Thank you so much for having me. Bye bye.
Bye.